Hi everyone, I'm Dr. Deed Harrison, President of Chiropractic BioPhysics Seminars and Technique, and I'm also President of Chiropractic BioPhysics, or CBP, nonprofit, which is a true nonprofit spine research foundation. What we've been doing is running through the Chiropractic BioPhysics nonprofit research publications in a video style presentation where I walk you through each one of our research projects, cover the key points, key aspects, highlight what it really means, and then we summarize. I've been doing this so everybody becomes aware of the type of information that CBP nonprofit has actually published in the peer-reviewed literature. Many people out there do not want to take the time or put in for basically a monetary subscription to some of these journals and actually sit down and read a research project. So I found out I actually get more attention from our research if I go through a video. What we have set out to do is cover each one of our research projects in a video format such as this. I spend about 20 to 30 minutes covering the particular project, and we try to launch these out once a week. This is a big project for us. We have over 150 peer-reviewed research papers in a variety of spine journals, chiropractic journals, and just simply biomedical journals. But you know, if everything goes right, we'll be doing this for a few years. This particular week, this is our 11th video in the series. And I've kind of decided to jump around a bit and not go in order based on some of the feedback that I get, and also just based on what I feel like covering that particular week. So what I've set out to do this week, and actually for the next few weeks, is cover a certain topic as it relates to the cervical spine. Specifically, we're going to be covering the AP view cervical x-ray and AP view cervical posture, and talk to you about a few of our projects where we've basically broke down different aspects of this. The first project we're going to be covering in this 11th video on head translations or AP cervical x-ray measurements is reliability. The first thing you've got to do before you do anything else in terms of treatment outcomes and assessments, you do have to understand and investigate the reliability of your assessment procedures. Chiropractic biophysics technique, one of the biggest things we do is we look at patient spine x-rays and we compare those x-rays to a patient's presenting posture abnormalities and their pain and disability and health status. So x-ray becomes a very important tool for us. We have a variety of different radiographic measurements, and we have to actually investigate the reliability of these measurements. So this week we're going to be covering our project that was published in the Journal of Manipulative and Physiological Therapeutics in the year 2000, Volume 23, Number 7, page 476 through 482. The title of the project is called Chiropractic BioPhysics Digitized Radiographic Mensuration Analysis of the Anterior-Posterior Cervical Thoracic View, a reliability study by CBP authors, including myself. Now, some people have looked at these videos and a few comments were, well, this is from the year 2000. Well, yeah, I'm giving you a historical presentation, but I want you to know it's consistent with what we know today. Just because the paper was published in the year 2000, 15 years ago, doesn't mean that it's still not true today. I can tell you that. X-ray line drawing reliability is simply reliability of the lines. It's established, it's valid, it's irrelevant what year this was published in. We still use this material. So what we're going to go through is this particular project. Now, first and foremost, we have to understand this project is not investigating the repeatability or reliability of x-ray positioning. That's a separate topic we'll address later in a different video. Now, what we need to do is understand the x-ray is actually passing through the patient's three-dimensional posture. So shown up here on the top is 3 presenting postures with my younger sister, who's my model. So I have permission to show her photograph, whether she likes it or not. She signed informed consent, and she's family. So if I get in trouble, forgive me. Anyway, this is a head rotation showing you how we x-ray that. And then right beneath it, what's shown is what the x-ray should look like. And then here in the middle is a lateral flexion to the patient's left side, and then shown beneath that is what the x-ray should look like. And then on the reading right, we show a head shift or head translation. where the head center of mass or center of gravity is shifted off to one side, in this case the left side, and then we show the relevant X-ray alignment. Now, we are investigating the X-ray alignment, and we're not really investigating the posture in this particular case. We're just investigating our assessment for these displacements that we see on the X-ray, and then later we'll talk about what posture it is and then how we correlate that to a patient's condition, etc. So this particular project is a simple reliability study, but very important. It's the foundation of what we would do. So what we did is we took 36 randomly pulled AP cervical thoracic X-rays. And cervical thoracic means the upper thoracic spine to the top or to the base of the skull, so we could see the upper neck as well. Then we had 3 examiners that were blinded to the patient condition and blinded to each other, assessed these radiographs 2 separate times. So the 3 examiners weren't in the same room with one another while they were doing the assessments. And there was a minimum of 1 day between repeat measurements of each examiner. So we call it a blinded repeat measuring basically protocol, right? So what we have is on the X-ray, we have 30 points that each examiner is going to assess or digitize on each of these 36 AP cervical radiographs. And each examiner, again, is going to have to do this twice. So you get the idea, it's a lot of work. Now, in this particular project, we have a computerized method, but we're also going to compare it to a hand-drawn measurement procedure so we can investigate what's called the concurrent validity of a new computer program. That new computer program now is in a commercial form available to chiropractors. It's called Posture Ray. Posture Ray. If you go to posturecode.com, you can look up and see this computerized assessment software that we have available. And it uses these background studies and the code that we did in this particular project for our assessment of our computerized method for radiographic analysis. Now, so it says here, a computer was responsible for calculating centers of mass of each vertebra. We'll show a picture of that. The projected lateral displacement of a vertical axis line of the spine from a true vertical position, along with the determined best fit lines for which provided the magnitude of different angles that we're looking at, and I'll show photos of that. We then did statistical analysis looking at means, standard deviations, mean absolute differences of each observer's measurements, inter and intra-class correlation coefficients using confidence intervals, and reporting the actual reliability. So we did inter and intra, so within myself and then between me and other examiners, for example. Now here's the points that we digitized. There's 30 points on each vertebra. The only vertebra that wasn't digitized is C1. We digitized C2 all the way down to T4. And 3 points on each vertebra were basically digitized or touched with a sonic digitization system. The points were the superior lateral mass of C2, and then the bisected narrow-waisted appearance of each articular pillar from C3 to C7, and then on T1, the narrow-waisted appearance of the vertebral body all the way down to T4, the narrow-waisted appearances of the vertebral bodies. And then the spinous lamina junction, or tip of the spinous, was digitized as well. Now, our lines are not actually drawn along these spinous processes. There's a special technique that we utilize to take these 3 points and identify what's called the two-dimensional projected center of mass of each vertebra. And then what we do is we take those centers of mass and draw a best fit line. I'll show that in the next slide. Also, what we did is we drew a vertical axis line, which is straight up from the center of mass of T4 vertebral body. Now you can see that this point is not on the spinous lamina junction or the tip of the spinous. So in fact, we're using what's called the projected center of mass, and again, I'll show you how we locate that. We assessed the center of mass or the base of the dens of C2 relative to this vertical axis line originating at T4. So that was one of the assessments. We did horizontal offset of C2 relative to T4. So here's the concept of the projected center of mass. What we do is if I look at a vertebra from bird's eye view and I see its lateral aspects. If I bisect those, meaning find the center, I find the geometric center or centroid of the vertebral body. Okay? Now the center of mass of the vertebra is not at the centroid, because the vertebra actually has parts in the back, not just the vertebral body. We know the center of mass or balance point of the vertebra is going to be posterior to this point right here. So here's the center of mass, here's the spinous lamina junction, and in a perfectly aligned vertebra and symmetrical vertebra, those points line up, right on the tip of the spinous. However, when I have a rotation about gravity of a vertebra, and then I take an x-ray, what happens is the center of the vertebral body, centroid, projects here, the center of mass projects here, and the tip of the spinous, or the spinous lamina junction, projects right here. Now the way we locate the center of mass is we simply identify the halfway point between the two measured points that we can identify. So this point is what we're interested in, and it's simply a best fit approximation halfway between the spinous lamina junction and the center of the vertebral body. So we're interested in finding the center of mass. And then what we do is we connect those with best fit lines. Okay, so here's the idea. Here's my best fit lines through the centers of mass. I can make an angle at mid-neck. It's called the cervical dorsal or CD angle. And I can also make an angle measurement from vertical from the lower cervical spine and upper thoracic spine relative to vertical. So my lateral flexion offset of my lower cervical and upper thoracic vertebral best fit line, that we call the rotation Z, or lateral bending, of the lower cervical, upper thoracic to vertical. So we have two angles, this one here and this one here, and then we have a horizontal offset distance that we're assessing. We're also interested in looking at the center of mass of C5 relative to a vertical line, right? Or even the line connecting C2 to T4. That gives me an idea of how far the apex of the mid-cervical spine is shifted off of the vertical axis line. Okay, so the results. Simple project, but very important. The computer code was written by our mathematician, Dr. Tad Yannick, quite involved to write this new code to assess these lines and angles. And then the statistical analysis was performed by the late Dr. Bert Holland, who was a statistician from Temple University, a very famous, well-known PhD statistician. So this is the intra-examiner reliability. So I have to, as one of the examiners, I was one of them, I had to assess the 36 films twice, once each on different days. And then I look at how well I'm in agreement between myself on these repeated measurements. So the translation on the x-axis of C2 relative to T4. My standard error of measurement, and I don't remember which examiner I am, so I'll just say I'm examiner number 1. 1.53 millimeters. That's my error in making the measurement of how far the top of the neck is off the lower neck or the upper thoracic. Look at the reliability estimate using intra-class correlation coefficients. 0.99, that's really, really high. That's excellent. 1.0 is perfect. I mean, when you look at this, the estimate is 0.99. That's like perfect agreement. My error is 1.5 millimeters, but I'm actually perfect within agreement of myself. Okay, and then the interval, how far are we off from this 0.99? I'm only off by 1/100th when I look at this. The estimate is anywhere from 0.98 to 0.99. And then the apex vertebra. How far, for example, is C5, or the apex of the cervical kink, off of the line connecting C2 to C4? And we look at that, and the apex vertebra, standard error measurement, 0.99 millimeters. And then the rotation Z of the upper thoracic and low neck to vertical, that lateral bending angle, here's my error in degrees, 1.13 degrees. And then my mid-neck angle, 1.52 degrees. And if you look at these ICCs, they're almost perfect. Okay, the intra-class correlation coefficients, remember 1.0 means 100% perfect agreement between repeated measures. When you see values that are in the 0.8s and ups, That's considered excellent reliability. When you see things that are in the high 0.9s, you just got to go, wow, this is incredibly reliable, at least from that examiner. Now, if you look at examiner 2 and 3, the same thing is found. We've got identical intra-examiner reliability between these or amongst these 3 examiners. Each person can get the same thing on 2 different occasions. This is huge, right? This is a big deal. And then when we go to the inter, how were my measurements on session 1 compared to each of the other 2 examiners on their session 1? So I look at mine versus examiner 2, mine versus examiner 3, and then I look at my second session compared to the other examiner's second sessions. So we look at reliability between each of the 3 examiners. And we look at this and we go, here's my standard error of measurements for inter. The translation, 1.12 millimeters. Apex vertebra, 0.8 millimeters. Rotation Z, 0.85 degrees. CD mid-neck angle, 1.22. Look at the reliability estimates. They're almost perfect. So we've got excellent examiner reliability. It means I can give this film to any trained chiropractic biophysics doctor, and they can get the same thing. They can get almost identically the same measurement within a millimeter and within a degree. This is a very important thing. That means a patient comes in, and I have an x-ray of that patient. All of us agree on what is happening in that cervical spine. This is a big deal. While this is a simple project, the reality of it is this is, at this time in 2000, this was our 6th reliability project that we did. All 6 of these projects, including this one, showed the same thing. We have excellent examiner reliability across our measurements for chiropractic biophysics technique for each of the views that we investigated. In this particular case, the AP cervical radiograph. All of these studies have reported low standard errors of measurement with high ICC values both inter and intra-examiner. The other important finding is that we found out that our computer method of sonic digitizing points on a vertebra, that was as good and was consistent with the by hand methods. This is called concurrent validity. We had to do this. We had to see, are our methods by hand comparable to this new computer code? So anybody using Posture Ray uses the exact same algorithms that we used in these earlier projects. So we just plugged that into a computer interface program, and now we've got Posture Ray. So these background studies, they established the reliability of Posture Ray's back-end system for assessing vertebral angles and distances, right? So the reality of it is, when I look at AP cervicals, I've got 2 AP cervical x-ray displacements. Different CBP doctors can assess these films and get the same reading. I can see that this patient is 31 millimeters off center, C2 to T4, that's my translation. I'm going to be within 1 millimeter of anybody else doing it that's trained in this technique. My mid-neck angle, the CD, cervical dorsal angle, I'm going to be within 1 degree of another examiner, so 20 degrees plus or minus 1. And then my rotation upper thoracic and low neck, 16 degrees. I'm going to be within 1 degree of any examiner that's out there. We know we can get the same thing as each other, and that's extremely important. If I can't get the same finding as you, it means it's not there, or it means something's wrong with the way we're assessing this, or something's wrong with you, or something's wrong with me. In other words, we can't use it if it's not reliable. Extremely important, right? Many things in healthcare, even done today, they haven't even been investigated for the basics of reliability. You don't even know if an examiner can get the same thing from session to session. And I'm here to tell you, you might not agree with that, but it's out there. There's many different categories of this going on, or many different examples of this. So this is very important. The problem is this. This project did not assess my ability to take the radiograph in the same manner over and over again. So that's a different project. Can I get the same finding from x-ray to x-ray? Is the spine stable on repeated measurements, right? These are different topics, so I don't really know yet if I intervene and make a change in these AP cervical alignments that we've investigated, I don't know, is that really a change that I did, or is it an error in the way I position a patient, or is it a normal fluctuation of day-to-day alignment in the spine? So those are different projects, and we'll have to look at those, and in fact we will in upcoming topics. We've actually addressed that, but I'll reserve that for a later topic. For now, what we've done is we've shown that our investigation for AP cervical radiographic line drawing reliability, we've shown both in between examiners and within examiners, we get consistent results. So our methods are reliable. And then just a summary from the article, given that reliability testing is actually the first logical step in separating the clinical chaff from the actual wheat, our findings now set the stage for the critical examination of the validity of these procedures. So now we got to look at, hey, when a patient presents with these findings, do we see an increase in pain and disability? Can I x-ray somebody repeatedly from session to session in the same manner? And then can my interventions change this? These are future projects. That's what this statement means. But we've done the baseline, ground floor investigation. Now we can build on that. Okay, simple project, but very important. It's actually an easy read if you want to, get that 2000 article from the Journal of Manipulative and Physiological Therapeutics. Hopefully you enjoyed that quick down and dirty presentation. What we have is, for patients that are out there, maybe this isn't the most clinically relevant presentation for you, but it does set you at ease. It says, the assessments that we use, they're consistent and repeatable across examiners. That should actually make you feel, better and safe about the procedures that we use, or that a CBP trained chiropractor would use on you. For patients that are interested in finding a CBP chiropractor, I'm going to strongly encourage you to go to our patient directory. It's called cbppatient.com. You don't have to contact me, you don't have to contact my webmaster. This directory, it's easy to use. You just plug in where you're located and where you want to find a CBP trained chiropractor. Now the best thing is to search for a certified CBP chiropractor. That's a chiropractor that has taken 7 courses covering 80 to 90 hours of material, where we not only go through, reliability of line drawing and how to do it, but we go through what we do and how we help patients, how we manage them. Okay? Look for a CBP certified doc. If you can find an advanced CBP trained doctor, that's somebody that's taken 14 different weekend courses with me that covers 180 hours of material. That's a lot of training postgraduate for a chiropractor. Those doctors will be listed as advanced trained. If you can't find an advanced or a general trained CBP chiropractor, then find somebody that's listed on our directory. What it means is they've studied CBP technique with a couple seminars, and also they've investigated it on its own. It's a good idea, though, to call those chiropractors and ask them if they actually do CBP technique. Their information will be listed on the web directory. You call them up and you find out, hey, do you do CBP technique, or are you just listed on the directory? Because once in a while you have somebody that just takes a course, they're not going to use the information, and they're just there, to generate a referral. So the best advice, best solution is call them up and ask if they do chiropractic biophysics. If they do, great, go to them. And maybe they're a doctor that's just early on in their certification process. They haven't taken all the courses yet, or they haven't tested out with us. There's many doctors that have taken all the courses but just didn't want to take the test, and that's understandable in some regards. The other thing is, for doctors, if you're interested in this, if you want to learn more about this, these videos are nice little tidbits. But if you really want to study and learn CBP technique, consider coming to our seminars. Go to www.idealspine.com and you can check out the doctor information there. Also, love to have you support Chiropractic BioPhysics. There's a couple ways to do that. You can go to our direct web link and support us directly with a monetary donation to Chiropractic BioPhysics nonprofit, or you can do that indirectly through Amazon Smile. When you make your purchase, just select Chiropractic BioPhysics nonprofit as your nonprofit organization. All right, thank you very much for your time and attention, and until next time, be safe, and I hope you have great health.